Question number 1, find the coordinates of the midpoint of the segment. Remember the formula for that is A plus B over 2. You add the endpoints, coordinates divided by 2. So negative 3 plus 10 over 2. That's going to give me 7 halves. Name the following line 6 different ways, and then select which one is not a way to form a line. You have to have 2 letters or 2 points that are on the line to be naming the line. So that means G is that one that is wrong. Name the angle in 3 different ways. We can call this angle E here. I don't like how they're using lowercase, but that's fine. D, E, F, D, E to F, that's fine. DFE does not. FED is fine. Those 2 are the same because it's just backwards. And then FDE is not okay. So those 3. Use the diagram. At the right is statement true. Angle 1 and angle 2 are vertical angles. That would be false. 1 and 2 are not vertical angles. Okay, remember vertical angles, like that would be 1 and that would be 2. Those are vertical. 1 and 2 here, if you remember, those are adjacent. So that would be no. A segment has endpoints at H and K, where 2 names for the segment. Right there. Label array with endpoint Z. So Z, determine an appropriate name for array whose endpoint is Z. So whatever my array is, and they're using W here, W has to be somewhere else. So Z has to be, because it has the endpoint, that has to be the first point. So we're looking at D here. If I had to name it, I'd name it ZW like that. Which I do have to do that. Part C here, ZW. For the graph shown to the right, AB, find AB to the nearest tenth and the coordinates of the midpoint of AB. All right, so AB, so this ordered pair here is at, what, 4, 7. So B is at 4, 7. And A is at 5, 6, 3. Negative 6, 3. Okay, so 4, 7. And B is at negative 6, 3. So our distance formula, remember that. Subtract your x's. So x2 minus x1. Square that. Add to it y2 minus y1. Square that. So I subtract my x's here. 4 minus negative 6. 4 minus negative 6 is 10. I'll square that. 7 minus 3 is 4. I'll square that. So it gives me root 100 plus 16, which is root 116. If you were to, let's get a calculator open here. So square root of 116, 10.77. They want nearest tenth, so that's that one. So I'm going to use this 7 and round that up. So 10.8 is what I'd be looking for there. So it's coordinates to the midpoint. Type as an ordered pair. So the midpoint, remember that formula, x sub m comma y sub m is equal to x1 plus x2 over 2, y1 plus y2 over 2. So again, adding my x's, 4 and negative 6 gives me negative 2 over 2. Add my y's, I get 10 over 2. So we'd be looking at negative 1 comma 5. And just double check that. Go negative 1 up to 5. Be right there where my cursor is. That looks like it's halfway in between A and B. It guarantees I'm right. This one we did many a times in class. They tell me to write an algebraic expression for G to K. So for G to K, I'm going to start right here at G. And I'm going to walk all the way to K. And I need to record the distances that I walk to do that. So first, I'm going to walk to there. So 2x plus 5 has to be part of my expression. Okay? But then once I stop and continue walking, the next portion would be just that red stuff. That's going to get me from J to K. Well, that red stuff is smaller than the 4x minus 1. The 4x minus 1 is all this purple stuff. Okay? What I'm needing to do here is recognize that that distance right there needs to be removed out of my 4x minus 1. If I look at that distance right there is the same as that one. Okay, so if I take the x out of that 4x minus 1 and write it as 3x minus 1, that's the distance that is red here. Okay, so that red distance is 3x minus 1. So add that in, so plus 3x minus 1, and that should then equal gk. Now, they say simplify, so I should have 5x's plus 4 is equal to gk. They tell me that gk is 19. They keep asking me to do some additional work here. So if that's 19, I'm going to subtract 4, so I get 5x to be 15. X will be 3 then. Okay, I think they ask you then what gh is. So I need x to be 3 to be able to find gh. Well, gh is just that distance. Okay, so it's not quite 2x plus 5. It's falling short this green distance again, which is x. So that distance right there that I just colored, that red distance, is just x plus 5. So if x was 3, g to h is 8. So that distance there is 8. That distance there, we said x was 3, would be 3. And now let's see what jk is. Well, jk, we already said that was 3x minus 1. So it's going to be 8 as well. So jk is 8. Now, it won't always be the case that gh and jk are always the same number. But think about this, is 8 plus 3 plus 8. That's 19, and that's my total distance there. So I know I've done things correctly here. Number 9, graph these points, determine if they're collinear or not. So 1, 3, 1, 3, 0, 2, and negative 4, 0. And the idea is, can I put one line and connect all 3 of those points? And obviously that one is not on that line, so those 3 points are non-collinear. Okay, use this number line to figure out what the value of y is. So if I look at this, they're saying RS is 6y plus 5. That's from here to there. ST from there to there is 3y plus 7. So those are the 2 individual parts that I want to add together. 6y plus 5 plus 3y plus 7. And it gives me my total of R all the way to T, which they're saying is 11y minus 4. So this is the segment addition. So I'll say 9y plus then 12 is equal to 11y minus 4. Add 4 to both sides. Subtract 9y from both sides. So we get y to be 8. Okay. So then the rest of this is kind of actually a built-in check for us. If y is 8, RS would be 48 plus 5, so 53. S to T would be 24 plus 7, so 31. And then if I put it in here, I would get 88 minus 4, which is 84. If you take 53 plus 31, you should get 84. So those are the 3 values then that need to go for RS, ST, and RT. Number 11, if angle ABD is 82, so that's talking about this entire angle right here is 82. You now know the 2 individual parts of 8x minus 9 and 7x plus 1. Those 2 add together to give me the 82. So that's going to give me 15x's minus 8 equals 82. 15x equals 90. X then has to be 6. If x is 6, then I come back in here and say that's 42 plus 1, so that's 43 degrees. Plug it in here, 8 times 6 minus 9. 8 times 6 is 48. Minus 9 should be 39. Take 43 and 39 and add them together, you get your 82. So ABC was the 39 degrees, DBC is the 43. This is a midpoint question. They're telling us that T is the midpoint of this segment. There we go. T is the midpoint, so that just means that that distance there and that distance there are equal. Well, PT, they're saying is 3x plus 9. TQ is 6x minus 9. So subtracting 3x from both sides gives me that. Add 9 to both sides, and so give me 18 is equal to 3x. Divide both sides by 3, x is 6. Now they don't care what x is, they want what PT is, so I plug 6 into there. So 3 times 6 is 18, plus 9 is 27. Just double check. 6 times 6 is 36, minus 9 is also 27, and that guarantees, because they're both the same, that I've done things correctly. So angle HLK is that angle right there. They want to know which one are you guaranteed by the picture for that to be congruent to. So it's got, what, 3 marks in it? So we gotta go find the other angle that has 3 marks in it. And it's this angle right here, which is BLC. Is one way you can name it, BLC. You could have named it CLB. Okay, you just cannot call it L because there's a, that angle also has vertex L. That angle has vertex L. So there's a lot of angles there that have a vertex L. So you got to use 3 letters. Here we got a straight angle idea. So that angle plus that angle should equal 180 degrees. It's the idea of a straight angle is that they sum to, that is 180 degrees. So 7x plus 9 is equal to 180. So I got 17x's plus 10 is equal to 180. 17x is equal to 170. X then is 10. If x is 10, then plug that in there. RQS would be 101 degrees. Plug it in there. 70 plus 9 is 79. Add those together. That's your check. You get 180, so you know you're right. All right, so these questions are understanding of vocabulary and postulate. It says linear pairs can sometimes be vertical angles. A linear pair are those angles there. Okay, angle 1 and angle 2. You have to form this straight angle. Okay, they have to be adjacent. There is no way that they can be, because they have to be adjacent. If you understand what our definition of linear pairs is, they have to be adjacent. Vertical angles, by definition, are non-adjacent, so that's a false statement. Adjacent angles can sometimes be vertical angles. We just answered that. Adjacent angles are angles like 1 and 2. Now, we don't have to have the idea of being 180. They could be, but they can never be vertical. That's false. The only time that, so that's a vertical angle, that's a vertical angle. Okay, we talk about how the rays of one angle are opposite rays to the other. 2 lines intersect, these 2 angles are vertical, 3 and 4 would be vertical. They, by definition, are not adjacent. Vertical angles can sometimes be supplementary. That would be true. And the one we know the most, if I give this my x-axis, my y-axis, that angle there and that angle are vertical, and we know that that's a right angle and that's a right angle. Add those together, you get 180. So vertical angles are sometimes supplementary. Adjacent angles can sometimes be complementary. Absolutely. Complementary just means they add up to 90, so I can have a 90-degree angle, and I have a ray there. Maybe this one's 30, maybe that one's 60. They would be adjacent, and they'd be complementary. That's true. Adjacent angles can sometimes be supplementary. Yeah. Saying we got that going on right here. Angle 1 and angle 3 here are adjacent, and they're supplementary. They're a linear pair. 3 and 2 are adjacent, and they're supplementary. Okay. If I look at this, that's angle 1, that's angle 2. Let's say this is 40 degrees and this is 140 degrees. They're adjacent, they're supplementary. That's a true statement. Angle addition postulate. All linear pairs are supplementary. That's true. Okay. That's the linear pair postulate, which states this right here. That's what it says. Okay? All supplementary angles are linear pairs. That's false. If we have supplementary angles, by definition, two angles whose sum is 180 degrees. Nowhere in that definition does it say they have to be a linear pair. So they could be that, and that would be a linear pair, but angle 1 might look there, and angle 2 might be there, where they're not a linear pair. Remember, linear pairs have to be adjacent. Supplementary angles don't have to be adjacent. So that's a false statement. This will be part D here. Insert the missing word. How many lines go through any 2 points? Exactly one. Exactly one. Insert the correct information. If two postulates, or sorry, two distinct lines intersect, they intersect in exactly 1 point. A. If two distinct planes intersect, they intersect in exactly 1 line. Through any 3 non-collinear points, there's exactly 1 plane. That's the idea. We in class we held our 3 hands up and put plexiglass on those 3 hands. And no matter where we removed them, they would have 1 plane passing through them. This postulate develops a number line in which each real number is paired with 1 point, and each point is paired with 1 real number. That's the ruler postulate. This is the segment addition postulate. Here, all we've got to do, if I find angle DAF's measurement, I'll find D, A, and then F. Okay, so this one is coupled with 90 degrees. F is 180 degrees, or we can use 0 in this case. But if they want DAF, they're talking about that angle right there. The way we're going to do it is we're going to take the absolute value of 180 degrees minus 90 degrees, and that's going to give you 90 degrees. So 90 degrees is the angle. All right, so we're going to do the same thing for EAS then. So EAS, so E is passing through 110 if I use that top row. A, and then S is going through 155. So I'm going to take the absolute value of 110 minus 155, and that's going to give me 45 degrees. I'm going to do the same thing for RAE then. Okay, so RAE. So R is going through, using this top row again, it's going through 40. A to E, E is going through top row is 110. So I'm going to go 40 minus 110, or 110 minus 40, doesn't matter the order because we're taking the absolute value. So it's going to be 70 degrees. CAS is the next one. C is going through, or AC, that ray is going through 25. A to S then, S was going through top row, be 155. So I'm going to subtract those. So 155 minus 25. Okay, so that's going to give me, what, 130? And then EAD. EAD, so E, AE, that ray is 110 again. D is, the ray AD is going through 90. So I'm going to go 110 minus 90 is equal to 20. This is vocabulary, so I'll let you do that on your own. Vocabulary, 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 vocabulary. Alright, so this looks like it's all should be vocabulary. I don't think there's any more postulates. Nope. Okay, so I'll let you do the vocabulary on your own. Okay. Scroll through these solutions real quick in case you need to go back and see anything. If you want to, there's your vocabulary solutions. If you have any questions, please do not hesitate to ask.